Okay, so let's talk about solving inequalities now. So for absolute value inequalities, the basic process is the same as equations, with one catch. So we start by first making two inequalities. So 2x minus 3 is greater than 7. Drop the absolute value signs. Okay? Now, this time, we're going to do 2x minus 3, and we have negative 7. But when we change to the opposite of 7, we also have to change our inequality sign to its opposite. And that's a property of the inequalities. So once we've figured that out, once we have our two inequalities, now we solve them just like we normally would. So you add 3 to both sides. So we have 2x is greater than 10. Divide by 2. So we have x is greater than 5. We also do the same to the other inequality. So we're going to add 3 to both sides. So we have 2x is less than negative 4. Divide by 2. So x is less than negative 2. What does that look like on a graph? How does this equate to what we've been doing in the last couple of days? So we have our inequality here. Negative 2 and 5 are my anchors. At 5, we are going to put an open circle. At negative 2, we are also going to put an open circle. X is greater than 5 tells me that I'm going to color in the positive end, the greater than end. X is less than negative 2 tells me I'm also going to color in the smaller end. So if you recognize this as a compound inequality, this is an OR. So your final answer would be written as x is less than negative 2 or x is greater than 5. So in this particular case, we have an OR inequality, compound inequality. Okay? The next example looks like a less than. So it looks like it might be an OR, but let's see. We'll do the same thing, except in this case, first we have to take care of that 7, because that's outside the absolute value sign. So we have the absolute value of 5x plus 3 is less than 41, right? 34 plus 7 is 41. So now we're going to separate this into two separate inequalities. The first one, again, is 5x plus 3 is less than 41. The second one is 5x plus 3 is greater than negative 41. And we do the same thing that we did before, solve each one separately. So we're going to subtract 3 from both sides. So we get 5x is less than 38. And divide by 5. So x is less than 38 divided by 5 is 7.6. You can write it like that. 7 and 3/5, as long as you've got that decimal there. Okay, the other one, we're going to subtract 3 from both sides. So we get 5x is greater than negative 44. Divide by 5. So x is greater than negative 8.8. Okay? Now let's see what this one looks like on a graph. Our two anchors are 7.6 and negative 8.8. So at positive 7.6, I'm going to put an open circle. And this tells me that I want to color this way towards the small end. At negative 8.8, I'm going to also have an open circle. And it tells me that I want to color towards the high end. So in this case, they are both traveling towards each other, so that means that we have, in this case, an AND inequality. Okay, this makes AND. Okay, so less than means AND. And we could write in one inequality together our final answer as negative 8.8 is less than x is less than 7.6. And that would be our final answer and the graph as well. So just to recap, when we have an absolute value inequality that has a greater than sign, that's an OR compound inequality. With the less than sign, you're going to have an AND inequality.